Engineer's transit. We use this to measure vertical angle, horizontal angle, and also we use this to determine the horizontal distances and vertical distances. Let's have here the engineer transit that used by the surveyors. So we have here the upper plate, the lower plate, and the head leveling head assembly. As you can see here, we have here a telescope. Inside the telescope, you can see here a crosshair, and in the telescope, there's above here you can see the attached vertical vernier. And you can see the upper screw that enables the telescope to rotate a 360 rotation. There's also an eyepiece in order for you to look at an object, and it has a focusing nuts. Also, at the left side of the engineer transit, you will also find another focusing nuts. In order to use the lower tangent, you should able to close the upper screw, and this tangent screw enables to move the telescope in a slower movement up and down in order to level the telescope. So if it is level, you can now proceed to measure vertical angle. On the right side, you will see the vertical vernier. In a vertical vernier, there's a number that is 180 degree that you can measure a vertical angle. As you can see here, it is not very visible because of this condition of the transit. So in order to rotate this, the upper screw should be open for you to able to read the vertical angle. So that is the upper plate assembly. So if the vertical wheel is in upper, it is said to be in direct position. If it is in lower naman or sa down, it is said to be in a normal position. We have also here a plate level vials. It is attached to the upper plate are two level vials which are positioned at the right angles to each other. The plate levels are used to establish the upper and lower plates in a horizontal plane. We have here a compass box. So the transit is usually provided with the compass box for establishing the magnetic meridian and to allow rough check on the measured angles. It is found on the upper plate between the standards. We have here the A vernier at the other side. So it has a scale to measure the horizontal angle. So A vernier also has a partner which we call the B vernier, and A vernier is 180 degree from B vernier. So it is used to measure the horizontal angle, and it is located on the horizontal circle. We have here the lower plate. In the lower plate, we have this lower clamp or screw. If you will release it or open it, the upper plate will be moved. As you can see here, the vernier A is moving. And if you will close it, and you will open the lower clamp here, as you can see, it is not moving, right? And if you will release this clamp here, if you will open this one, you will see that the lower plate is moving but the upper plate is not moving. So that's why the vernier is not moving. The lower plate itself is rotating. Okay, so that's the function of that lower clamp here. And if you will close it and close the upper clamp, you will open this tangent screw. The tangent screw will move slightly on left or right, that's the tangent screw here, it will be often move slightly right and left to measure the horizontal angle accurately. So that's the function of the lower tangent screw.
The leveling assembly. So sa leveling assembly, we have the leveling screws. So we have 4 leveling screws. In this particular transit, we have 4 leveling screws. So sa ibang transit, we only have 3 leveling screws. Also, sa leveling head assembly, we will also have the plumb bump. Kasali siya sa parts niya. Then we have this plumb bump attached in the leveling head assembly.